Okay, welcome everybody to this session. My name is Feidhlim, and I'm going to take you through a couple of our top highlights in vSphere in VCF 9. Then I'll hand it over to my colleague Pete, who will talk through vSAN, and lastly, Francois will give us some what's new in NSX. So one of the first things let's talk about is live patch. Now, live patch isn't intimately new in VCF 9. We did release this in vSphere 8 Update 3 and VCF 5.2. But what we've done in VCF 9 is we've expanded the surface area of ESX that is now live patch capable. In the previous release, only the subsection of ESXi that was corresponding to the VMX, or the virtual machine execution environment, was live patch capable. And actually, up until now, we actually have not delivered a patch that is live patch capable. We're hoping that's going to change in VCF 9 and that it will be more of the norm that our security patches will be able to leverage live patch, because we've expanded it to support the areas of the VM kernel, the user space, so host D, VPXA, those sort of services, NSX components, and the VMX as well. And actually, there's one component here that is off the slide, and it's also VMware Tools. When we're updating the VIB for VMware Tools within the ESX host itself, there are instances where that can be done using live patch. Now, if you're unfamiliar with live patch, what it essentially means is we can patch ESX in place without having to evacuate the entire host of all your running virtual machines. Because in a typical lifecycle operation, the actual act of patching ESX is relatively quick. You patch it, you reboot, and it's done. Where the length of time takes is the evacuation. Evacuating 100 VMs from a host can take a long, long time. By being able to leverage live patch, the VMs don't have to move. They can stay in place, you can perform the patch, and it's much, much quicker. And we're hoping that this will allow customers to adopt those important security patches much, much faster. Now, one thing that virtual machines will undergo is what's called a fast suspend resume. This isn't a new technology. This is something that your VMs have been doing for a very long time. Anytime you do a hot reconfiguration of a virtual machine, add a NIC, add a disk, change memory, change CPU, we're undergoing what we call a fast suspend resume. And we've actually made that process even faster again for those vGPU-enabled virtual machines. So we're hoping in VCF 9, going forward, that our important security patches will be able to leverage live patch at a more frequent cadence. Now, another area in the lifecycle space that we had a lot of customers request from us is support for mixed vendor clusters. When we first introduced vSphere Lifecycle Manager back in vSphere 7, it was a little bit restrictive in that it typically required your clusters to be homogeneous, be the same vendor, same model in certain circumstances. In VCF 9, we're allowing you to define still a single, what we still call a single cluster image, but it has additional images embedded inside it, almost like child images. And it's these child images or these additional images where you can have some additional flexibility and customization. Now, while the entire cluster, all the hosts in the cluster need to be on the same ESX base version, you could have a mixture of, let's say, for example, in this screenshot, 4 HPE hosts and 4 Dell hosts. And we can have the mix of the vendor add-on for HPE hosts, have a different hardware support manager, different components to satisfy that particular model and vendor, and do the same for the Dell hosts. And we can have up to 4 additional images per cluster image. So in theory, this allows you to support up to 5 different hardware vendors per cluster, but we still would recommend, where possible, to make things homogeneous, because it does make things a little bit easier in the long run. Now, the next large feature in VCF 9 for vSphere is memory tiering. Memory tiering was a tech preview in vSphere 8, and now it's a fully supported GA feature in VCF 9. In a nutshell, memory tiering allows us to leverage fast NVMe devices as a second layer of memory. So it allows us to get additional capacity for our hosts and add additional virtual machines to those hosts. Memory tiering is transparent mostly to the user. You can enable it and disable it at a per VM level if you choose, but typically it's enabled at a cluster level. And automatically the hypervisor will move hold pages to the slower NVMe tier memory and keep hot pages in the fast DDR memory. We've done a lot of work over the years in our vGPU story, and we're continuing that in VCF 9. One area is making vMotion even faster and less disruptive for vGPU-enabled VMs. You know, we take vMotion for granted in the traditional sense. Large super monster VMs can vMotion without problems. We found that with vGPU technology, that the stun time is a little bit more susceptible to the applications being interrupted. So we've done a lot of work with our GPU partners like NVIDIA to be able to work and reduce that stun time down from 30 seconds, 40 seconds, sometimes even more than a minute to less than 2 seconds for quite large vGPU profile sized VMs. So this is a major performance improvement for copying vGPU enabled VMs from one host or migrating them from one host to another. And like I mentioned with the live patch instance, doing the fast suspend resume is even faster again and less disruptive for these workloads. This is important because of the proliferation of AI/ML workloads. More customers are purchasing GPUs, running GPU-based workloads, and we want to make sure that they have the exact same mobility as non-GPU workloads. We're also adding some visibility, capacity, and placement visibility baked into DRS and showing up in the vSphere client. This allows an administrator to see at a glance what is their total GPU capacity across their cluster, across their fleet, and see at a profile level how many more vGPU-enabled VMs do I have capacity for. So it'll help you forecast for additional workloads and see, do you need to scale up? Or it can also help you identify vGPU-enabled VMs that maybe are using too much GPU resources. Maybe they can have their profile size reduced down to free up additional resources. And staying with GPUs and DRS, we've made the GPU DRS placement much, much smarter, even more smarter now than vSphere 8. Now we can actually future-proof by placing reservations on our GPU resources ahead of time. This is extremely important for better capacity planning and ensuring that you have the right performance and the best operational efficiency for those GPU workloads. So GPU DRS will make better placement decisions. It'll move vGPU-enabled VMs and consolidate them onto available resources to free up space for reservations of not only CPU memory, but now GPU reservations can be set. And this allows for those large scale VMs to ensure that they have a place to go and that they can power on. And lastly, just with most of our vSphere releases, we always introduce a new hardware version. VCF 9 and vSphere 9 is no different. We're up to hardware version 22. This comes with some of the typical maximum increases, like CPUs is going up to 960 vCPUs. It brings support for the latest Intel and AMD physical CPUs, as well as the latest guest operating systems. It's also required for the tech preview of AMD SEV SNP and Intel TDX, and some additional guest customization, virtual NVMe, and 4K block sizes. So that was a very quick look at vSphere in VCF 9. And now I'm going to hand it over to Pete, who's going to take you through VSAD.
All right. Thank you very much, Feidhlim. Let me go ahead and share my screen, and we'll get started on this portion of the presentation where we're going to take a look a little bit about what's new in vSAN. for VCF 9. A lot of really exciting new capabilities and features. We're just going to cover a few of them. But the first one that I wanted to share with you is the introduction of a brand new global deduplication capability within vSAN ESA. This is really about lowering the total cost of ownership and, in particular, storage within your environment. And it's extremely important given the fact that now, remember that when you have your VCF licenses, you have an entitlement of vSAN storage that comes with it. So imagine this ability where you have this entitled amount of storage available to you, but you can store even more data courtesy of global deduplication. So let's take a look at what this looks like in a little bit more detail. First off, one of the new things and the new capabilities around this type of deduplication is that it is cluster-wide, meaning that we're going to be looking for duplicate data that exists across the entire cluster. And the reason why we're doing this is that when you increase the deduplication domain, you increase the probability or the likelihood that you're going to be able to deduplicate the data. That's going to result in much more cost savings and much more space efficiency as a result. We also deduplicate the data at a very small or granular level, 4K blocks in particular. And this also increases the likelihood that you're going to find duplicate data. Now, one of the things I think that is really important here, and was one of our design goals here with this new feature, is that we wanted to make sure that it didn't impact the performance of the guest VM workloads that you have in your environment. So this process is a post-processing activity. It's going to run asynchronously, meaning that the data is already going to be written to the persistent storage media, but at a later time, when vSAN recognizes that there are spare CPU cycles and so forth, it's going to perform some of these processes and throttle up when there's certainly more free resources and throttle back down when there are fewer free resources. So really intelligent, really easy for you to employ in your environment, and no need to offer any sort of tuning or anything like that. And of course, this is all fully compatible with the variety of services that are offered within vSAN. Now, deduplication is going to be, it's really going to be a part of a limited availability program here for VCF 9, and it's going to be a part of patch 01, which will be shipping sometime shortly after the GA of 9.0. Now, you might be thinking, you may have a storage array that certainly does deduplication very well on its own, and it might very well be the case. But what's the difference between that type of deduplication and what you might see within vSAN? Well, within a storage array, you have a deduplication domain typically of the actual storage array itself, meaning that when you add an additional storage array, you're then splitting up the deduplication domain, lowering its overall effectiveness. Well, with vSAN, global deduplication, anytime that you have a vSAN cluster that has this enabled, as you grow and as you scale that vSAN cluster, that deduplication domain is also going to grow, and that's going to increase the effectiveness of the space efficiency capabilities within global deduplication. So extremely powerful. Now, moving on to vSAN storage clusters, which is our sort of centralized shared storage solution for your vSphere clusters, as well as other vSAN clusters. We're introducing a new capability called network traffic separation. And what this does is this allows you to use an additional VM kernel port on those hosts that make up your vSAN storage cluster, so that it can be, that additional VM kernel port can be responsible for transmitting the data that is performing the back-end storage activities like rebalancing the data, making sure that it's resilient and replicated elsewhere, and repairing the data if need be. And what this is going to do is it's going to increase the effective performance of vSAN storage clusters. It's also going to make your network much more efficient as well. So imagine a scenario where you could have a vSAN storage cluster sitting within a single rack. The back-end vSAN activity, or that storage traffic, could remain within the top of rack switches, while the guest VM IOs are transmitted across your network spine to the vSphere clusters that are mounting the data store. So this is really going to offer a much more efficient and effective way and a flexible way for you to deploy vSAN storage clusters. Now, one of the new capabilities within vSAN for VCF 9.0 that we're introducing builds off a capability that we first introduced in vSAN 8 Update 3, or as a part of VCF 5.2. And this new capability is known as vSAN to vSAN replication. What we're doing is we're extending the capabilities first introduced, um, which was known as vSAN data protection, which sort of uses vSAN ESA's highly efficient and effective snapshotting engine to provide a mechanism in which you can sort of use snapshots in a way that you always envisioned. You can easily make and protect those VMs at given points in time, set backup schedules, and retention schedules for those given snapshots. Well, we've extended that ability to now provide VM level protection beyond just the local vSAN cluster to protect that data to a remote vSAN cluster. Now, this all occurs within the given or the same UI that you experience using vSAN data protection. It's just simply that we extend it to have a target as a remote vSAN cluster. Now, this does require the add-on license of VMware Live Recovery. But what that does is that it also provides you with the orchestration capabilities to provide a full failover mechanism or a failback or a recovery mechanism as a part of VMware Live Site Recovery, which was previously known as Site Recovery Manager. This is really going to be able to give you the ability to either augment or enhance some of your recovery capabilities for your given VMs and running through a wide variety of scenarios, whether it's DR, ransomware protection, and so forth. Now, for customers who are using vSAN stretch clusters, we've introduced a few new enhancements for those types of topologies. They've been extremely popular for many of our customers over the years, and we get a lot of requests for them. So we're really excited to share some of these new improvements as well. First off is that we're announcing support for stretched vSAN storage clusters. And what that would be is that you have a vSAN storage cluster that resides in two geographic sites that is connected via an intersite link. And that part, of course, we have had support for it previously, but this new enhancement allows you to take a vSphere cluster that is mounting that data store and stretch it across those two same sites. And what that's going to do really effectively is this is a much more effective and a much simpler way to, in a sense, create a metro storage cluster. Those have historically been much more challenging to not only deploy, but to maintain and scale and so forth. vSAN has had a long history of being able to provide a really effective stretch cluster arrangement, but this ability now carries over into this notion of you can still have centralized shared storage via a vSAN storage cluster, but stretch it across two sites and also have your compute instances fully site aware in the event that there was a site outage. Now, next up is that we're introducing a new capability within vCAN for VCF 9 that provides you the ability to enter an entire site to maintenance mode. Many of you are very familiar with entering a host to maintenance mode, whether it be a vSphere host or a vSAN host. But we had many of our customers want to enter an entire site to maintenance mode. Let's say they had to work on some of their network switching at the one site or perform some other maintenance activity. This is now included within the UI and will walk you through with a single click the process of migrating workloads, ensuring that all of the sufficient pre-checks have been done prior to the step of entering each host within that site to maintenance mode. And then, of course, it doesn't stop there, in that when you're finished with that maintenance process, it will walk through the process of exiting those hosts out of maintenance mode and sort of bringing back sort of the state of the cluster prior to that maintenance activity. And thirdly, we have the new ability to introduce a new recovery method if you were performing maintenance activity on one of those sites using the site-wide maintenance mode feature. What this will do is that if you have an event where you have a double failure of the two remaining sites that were available during this period for a site-wide maintenance mode, it will allow you to take that one site that was in maintenance mode and exit it out of maintenance mode, but also recover the VMs and the data so that you can get those VMs back up and running and in a production state. This is really important for those scenarios where there has been a double failure for those other two sites, and there is some probability that you may not be able to even recover those two specific sites. So in the past, this was something that you could perform, but you needed the assistance from our global support team, but now this is a self-service activity. Within vSAN for VCF 9, this is going to be introduced in limited availability, but then I would envision this be a part of the more widely available in subsequent releases. Now, next up, we really wanted to make sure that we have improved the management and the monitoring of vSAN really at scale. You can monitor and manage things at a small scale fairly easy. But when we're talking about VMware Cloud Foundation and you having this virtual private cloud in your environment, we want to be able to make sure that you can look quickly and easy over a wide number of clusters, sometimes dozens or even hundreds of clusters that are running in this VCF instance. So we've introduced 3 brand new dashboards for VCF operations that were built specifically for vSAN and some of the day-to-day activities that you would want to perform. First up is a vSAN storage operations dashboard. This is really your at-a-glance understanding of what's the health and well-being of those vSAN clusters. Rather than clicking on each and every vSAN cluster and looking at the health check dashboard and alerts and so forth, this is going to provide that consolidated view, so you don't have to do that. It's also going to serve as the launching point for understanding vSAN performance, which will redirect to another dashboard. And this is a new dashboard that is specifically geared so that you can look in a very simple fashion on the primary performance metrics that you would have for your various vSAN clusters, but do so in a way that you can quickly compare them as opposed to jumping into each and every vSAN cluster. Now, thirdly, we have an additional vSAN dashboard that focuses on performance diagnostics. This is really there for two scenarios. One is that if you're spinning up a brand new vSAN cluster, you want to do a little bit of a sanity check, make sure that everything is fine before you roll it in to production. This is going to provide you the tools to easily perform that. It's also going to perform some diagnostics capabilities for existing vSAN clusters so that you can make yourself aware of any issues that may currently exist within that given vSAN cluster. So those are some of the brand new capabilities within VCF operations that are geared specifically to vSAN. And this really sort of ties back when we think about these capabilities that I shared. We need to remember that you've trusted that hypervisor for many years to sort of manage those workloads. So it sort of makes sense to let it manage your storage as well. And given that vSAN is a part of the hypervisor and its licensing, why not use it? And with this brand new capability that you have to granularly protect those VMs, this offers all new opportunities for you to do so as well. So that concludes my portion of the presentation, and I'm going to hand it over to Francois, and he'll show what's new with networking.
Thank you, Pete. So in this section, we're going to talk about VCF 9 networking, and we're going to talk a lot about the virtual private cloud. So what is a virtual private cloud for us? Basically, it's an environment where you can easily define networking and attach your workloads to those networks. You have complete control about the connectivity inside your VPC between your different workloads. The VPC itself can be easily deployed through a user interface, and it can also easily be deployed via API. Finally, there is a concept of multi-tenancy and isolation. You can spin up independent virtual private cloud. You are in your dedicated workspace for your networking, compute, and storage, basically. That's what we're trying to achieve. Remember, VCF 9, our goal is to provide a public cloud experience for your private cloud. So how does it work in VCF? Basically, I'm zooming on a VPC with two virtual machines and two independent virtual networks called subnets here. Of course, well, this is VMware. Your workloads, your VMs are running on ESX hosts. But when those ESX hosts are prepared for VCF, you automatically get configuration for several features like vMotion, vSAN, and you also get the networking configuration for what I call here vNetworking, which is NSX. So behind the scenes, NSX is capable of routing traffic between those different virtual networks, those different subnets, thanks to the instantiation of a virtual router. And of course, those subnets don't exist in the physical infrastructure. So when you need to send traffic between two ESX hosts on the subnet, this traffic needs to be tunneled, and that's where our vNetworking pre-configured network is going to be used to tunnel this traffic between ESX hosts. But this is just the way it works behind the scenes. What matters for you is that you have simple compute, networking, and storage in your virtual private cloud. So the next few slides are a little bit more technical, but if you can suffer through them, I'll have a little demo that will hopefully show you how simple all this is. So because we have a multi-tenant environment, we also have very specific roles in order to support this model. First, you have the enterprise admin, which you can see as being the NSX admin. This person has complete access to the physical network and configures the connectivity of NSX to the physical infrastructure. They also have the responsibility of creating projects, and you can see project as being a first level of tenancy, something like Project Pepsi versus Project Coke. And they also allocate IP block, which are global resources and global IP pool that will be distributed to the different projects. So at the level of the project, we have a project admin. So this is mainly an admin that is responsible for those different tenants inside your environment. You have multiple project admin. You only have one enterprise admin in theory. And the role of the project admin is to create those virtual private cloud and assign IP blocks to them. And finally, at the lowest layer, you have the VPC admin. And the goal for the VPC admin is to be basically a user, a consumer of networking. And this person is mainly responsible for instantiating, creating on-demand subnets, and attaching their workload to them. So this structure looks complex, but I introduced this for a very simple reason, is that there is a clear segmentation of the roles that allows for pre-provisioning most of the complex stuff ahead of time. Basically, the enterprise admin has configured the physical connectivity. The project admin has distributed this connectivity across multiple VPCs. And as to the VPC admin, the only thing they need to do is to click a button, they get a subnet that is immediately usable with full connectivity, and they just need now to attach their VM to it. All this is possible, well, thanks to NSX, of course, and also bear in mind that we have an elaborate mechanism of quotas that trickles down, I would say, from the enterprise admin to the project admin and finally to the VPC, so that a given VPC admin cannot, of course, use all the resources of the VCF platform. So a little bit more technical now, how does it translate into our NSX stack? So at each layer, we have some virtual components. I'm going to quickly go over them. So at the level of the enterprise admin, you configure what we call an external connection. This is the way we are going to connect to the physical network. And we'll see that you have two ways of doing that. The traditional way, I would say, which is a centralized way, or a new way, which is a distributed external connection. We'll go into the detail of that later. At the level of the project and under the control of the project admin, you have a transit gateway. And finally, we also have a VPC gateway instantiated on each and every VPC. And those are responsible for interconnecting your subnets. So all those gateways, I'm just showing them here in order to understand how the stack is built, but from the perspective of the user, meaning the VPC admin, you only see the subnet. You don't really care how your subnet are connected to the outside world. The only thing that matters to you is that they work and they can be easy to deploy. So let's focus a little bit on the external connection. We have two models for this external connection, a centralized external connection. And I said it's a traditional model because in that case, you're basically going to instantiate a tier 0 gateway on an NSX edge. And the transit gateway, which is at the level of the project, again, is going to be associated to this tier 0 gateway. The tier 0 gateway is peering to the outside world with BGP and advertises the network that are being used by NSX. If you want the full picture, here it is. You most likely have redundancy. You have multiple instantiation of the tier 0 on different edges. And you can see the VPC gateways distributed on each and every ESX host. This model is the most feature-rich because we use the NSX Edge appliance that can run centralized services, so we can do NAT, DHCP, QoS profile, gateway firewall with a vDefense license. And this model is required if you do advanced stuff like the supervisor cluster and VCF automation modern experience. So now let me go one step further and introduce a new way of connecting your NSX environment, your VPC environment, to the physical world. And this is a distributed external connection. So the big news here, what is really standing out, is that you don't require an edge in order to get connectivity to the physical network, thanks to this distributed external connection. Basically, what it does is that the transit gateway is distributed on each and every ESX host and will be capable of routing directly the traffic from your virtual environment to the physical fabric. So that looks maybe too good to be true. There is a significant requirement that you need to meet in order to benefit from this model, is that you need to have a VLAN that can span all your ESX hosts. So all your ESX hosts are attached to a single VLAN, or you can have multiple of them, but at least you need to have one VLAN that span all your infrastructure. So that looks like a significant constraint, but we have a lot of customers who have the capability of doing this kind of extended layer 2 network across their whole data center thanks to advanced feature in their physical network. I'm talking VXLAN, EVPN with VXLAN, or ACI maybe with Cisco. So if you meet this requirement, you will be able to deploy a VPC environment without creating any edge. And remember, this environment here is pretty much available as soon as you have deployed VCF. Basically, you're almost ready to run this environment. And I'm going to show you a very short demo that will illustrate that. So I have a very simple environment with just two ESX hosts that are attached to one VLAN 10. And on this VLAN 10, you'll notice I have provisioned a very large network. It's an RFC 1418. Actually 1918 subnet 10.0.0/16. This is you can see this as a big pool of addresses that NSX can use basically. I'm going to attach my distributed gateway to this VLAN, and thanks to this I'll be able to create VPCs and subnet in a very simple way. So first we need to configure this distributed external connection, and as of VCF 9 you have this workflow available directly in vCenter. So vCenter offers a special project in this hierarchy I showed earlier on, a default project where everything can be configured from the vCenter admin. So here I'm just going to the networking tab, and you see that there are some new tabs for VPC, VPC subnet, and network connectivity. I'm going to click on network connectivity. And I'm going to select this distributed connectivity. The next string, oops, sorry, I did it twice. Yeah. Now I'm going to basically enter the parameters describing this external VLAN. So I'm entering the default gateway, which is 10.0.0.1. This is VLAN 10. And again, this is a block that you can consider as being a pool of addresses that we can distribute to our VPC when we need it, let's say. We'll see later on. So I click deploy, and that's the only configuration that is needed. Again, you can do this straight after deploying VCF 9. That's the only step that is necessary if you have this VLAN spanning everywhere. So I click deploy, and I'm going to start configuring a VPC. And you now have a new tab that allows you to create a VPC. And creating a VPC is very straightforward. It's mainly a matter of giving it a name and giving, again, an IP block that is a range of private addresses for the VPC. So basically what it means is that when you create private subnets, on this VPC, there are going to be allocated sub-blocks of this large /16 block I've defined here. And this block is private, it only exists within VPC, so you only have connectivity inside the VPC with this block. So I click Save, and I have my VPC that has been created, and I'm going to start creating subnets. So I have two VM, an app VM and a web VM. I'm going to create a subnet for each of them. I create an app subnet, and I'm asking for a size of 256 IP addresses. So basically, we assume that the VPC admin doesn't know what a /24 subnet is. And I'm going to ask NSX to instantiate automatically a DHCP server for this subnet so that my virtual machine can get automatically an IP address. When this is done, my subnet is immediately created, and you can see that it has been allocated 172.16.00/24. So it's a subnet of the /16 that I had specified earlier on, as expected. The default gateway is .1, the DHCP server is .2. I'm going to quickly create another subnet for my web VM. So I'm using exactly the same parameter, So this is a private subnet. And now I'm going to attach my virtual machine to each subnet. vCenter gives you a nice graphical representation of your environment, and you see that our web subnet has got the next/24 available, which is 172.16.1.1 is a gateway. So now I'm attaching my web VM to the web subnet. And you'll see that this procedure is exactly what you were doing when you were attaching a virtual machine to a DVPG. So it's exactly the same, and it's just as simple as attaching a VM to a DVPG. You can still attach a VM to a DVPG, so this VPC subnet option is new, and if you click on network, you'll see the DVPGs available on vCenter. So I'm attaching my web VM, and I'm also going to quickly attach my app VM. So at that stage, you can see that my web VM has retrieved an IP address with a DHCP server, and a little bit as expected is the next one that is available after the address of the DHCP server itself. And not shown here, you also have an IP address for my app VM that has been assigned by DHCP. So now we've configured everything. Does it work? I'm going to show you that very quickly, but first, I'm going to assign an external address to my web VM because I want this VM to be accessible from the outside world. At that stage, those VMs only have private addresses. They can talk to each other within the VPC, but they cannot reach the outside world. So I just selected my web VM and assigned an external IP address with it. It's something that is straightforward from the UI. And you can see that it got 10.0.0.2, which is an IP address that we define in this VLAN range, in the block that is on the VLAN. That is an external address that is known by the physical infrastructure. So we can reach into this VM thanks to this external address. And I'm going to ping it from my workstation, and I'm going to SSH into it. You will see that thanks to that external address, I can SSH into my VM. You can see that this VM still has its private IP address, but we reached it through 10.0.0.2. So automatically NSX is doing some NAT translation for us. And once I'm in my web VM, I can SSH into my app VM. So this is just highlighting the internal connectivity through the VPC gateway from subnet to subnet. So all this is very short, of course, but the only thing I want you to remember from this slide is that it is very easy to deploy subnets and attach VM to them, and you immediately get the connectivity you require. And just compare this to what it would mean to achieve the exact same lab with just plain vSphere networking, where you have to map your DVPG to VLAN in the physical infrastructure. That's a lot of work in the physical infrastructure. Here, you're basically benefiting from a self-service model for your networking needs without having to go and configure the physical infrastructure. So this is my last slide, and I want to mention that we are changing the default VDS mode for VCF 9. So we already had an enhanced data path switch with higher capabilities compared to the standard VDS. If you are deploying a new VCF 9 environment, we're going to default using this EDP standard switch. If you are doing an upgrade, you will remain with the virtual switch that you are using. So just as a reminder, what are the benefits of the EDP switch? Well, you don't need any tuning, just like a regular VDS. It has much higher performance, and it doesn't require any, it doesn't have any hardware requirement on the NIC. So basically what it means is that we have emulation in software for the feature that any NIC cannot deliver in hardware for our enhanced data path switch. And even with this emulation, we're confident that it's going to be higher performance than the regular VDS. Finally, you have what we call an EDP dedicated mode, where you can do really fine-grained tuning and allocate CPUs for polling your NICs and having low latency switching. This is really advanced, and you probably don't want to do this by default. That's my last slide. And I'm going to end by recommending that you attend VMware Explore this summer. Just scan the QR code for more information. Attending there, you'll have access to lots of great sessions and also some free VCF certifications. Thank you very much.